Hello and welcome back to Jules Bench. My name is Greg Perugini and this lab is on calorimetry. Now in the previous lab we heated up water, and knowing the specific heat and based on this equation we were able to determine the amount of energy in the change in temperature of this water. In other words, if I add so much energy, it's going to change the temperature for a certain amount of mass at a certain specific heat. We can use this methodology to discover more than the amount of energy that will change the temperature. We can use it to discover the specific heat of another material, what it is made of. And we're going to do it for this ring. And we're going to use calorimetry to do that. So the first step is to heat this 250 grams, again filling it to that level, to a temperature of, let's say, 75 degrees. You can calculate how long you have to heat this up to get to that based on the last based on your microwave and your last lab. You should be able to calculate how roughly long to cook that water, and that will be your temperature of water initial. Next, you're going to freeze the ring. Put it in your freezer. And you're going to have a temperature of it, and you can put this thermometer in the freezer so that you'll know the temperature and get that settled as to what the temperature of the ring is at that particular time. And that's the temperature of, we don't know what the material is, but it's initial. So, let's list what we know and what we don't know. Okay? We know the specific heat for water, 4.186 joules per gram per degree Kelvin. We know the specific heat of the ring. No, we don't. It's unknown. We get the temperature initial of the water, measuring it right out of the microwave. We know the temperature of the ring because we froze it, and we could get that with the thermometer in the water, in the freezer, excuse me. And we're trying to calculate, as we put this ring in, put the ring in the water, put the top on, and put this in, obviously the ring is going to lower the temperature. And it's going to lower the temperature once we reach an equilibrium where the temperature is settled down. That's going to be your temperature final. Again, we know that we have 250 grams of water, and we know that the ring is a mass of 40 grams. So given all these things, and given this equation, we should be able to solve for the specific heat of the unknown material. So, as I said, heat up your water about 75. Take it out of the microwave, put the top on immediately, and place the temperature probe in it, verifying the temperature. Then take the ring out of the freezer. My freezer was negative 20 degrees. Yours would be settled in, whatever it is, you can check that ahead of time. And quickly take the top off the container, place the ring in the water, and close the top. After a minute or two, you can swish it around if you wish. You will get a new equilibrium temperature. The water will drop in temperature because you put the frozen item in. The ring is cooling the liquid. So this needs careful measurements. You may need to do this several times. The ring won't drop at too many degrees, okay? But it will drop at some. So that's what we're trying to do. We're trying to calculate the specific heat of the ring. Do several trials. Compare your specific heat with various metals. You could look up the metals. The metal might be steel. It might be zinc. It might be, I don't think it's lead, but it might be any various composite. But you should be in that neighborhood for what you see on the internet for specific heats of various metals, and answer all the other questions on the lab. So good luck.